All right, so this is the last of the recordings for this section. And what we're going to do is talk about optimal theory, but instead of talking about foraging theory, we're going to talk about optimal size theory. So for animals, what's the best grouping you can have? And so here is the idea with something called a northern bobwhite. So they've done studies on how big these groups are. They're found in groups, and kind of what is the best covey size. And in northern bobwhites, they find that number to be right around 10. Here's the problem. What happens is there's too few of you. You don't get the group protection, and you don't get all the other benefits. One animal finds food, and then you can follow that bird to find food on your own. Finding nesting mates, all of these things come into play. Maybe even a little bit of protection if a predator approaches, the dilution effect, all of these things have some sight. But the problem is if the number gets too great, you get maybe too easy to see by predators. Also, then you may have too much competition for food. Things like that. So really the kind of the magic number in this bird species is 10. So just to kind of give you an idea, there's a benefit for being solitary or in a group, and then what size is your group. So this idea came up by Hamilton. We've seen him before. And he came up with the selfish herd theory. And it's kind of this game theory is what do you do? Is it better to be solitary? Is it better to be in a group? And depending on the species and depending on your predator, it varies. And so in penguins, obviously, because of resources and other factors, the large groups are a lot more successful. All right, so in the red-shanked bird, they also found that the groups are better, but it turns out if you watch them, they actually keep their distance from each other. There's kind of this magic distance because if they're too huddled up and a predator comes in, you could get hit on accident. It might not have been, it's just going in for a group and you happen to be the one that's nailed. So there's actually a distance they keep from each other where it is safe. So if the predator keys on your neighbor, the chance of you getting hit is a lot less if you're just a bit farther away. And so when we see these flocks, when they fly, they tend to have kind of this bird length between them to make sure that they're not picked off. And so this is kind of hard to understand, and we're gonna do a little thing in the Zoom, I think, try to help you figure this out. Let me tell you what the letters stand for, and I think that's part of the problem. When you think of P, P is going to stand for your potential benefit. I would almost call it a B, but anyway, there's P is okay. If you're by yourself, here's all your potential fitness. I guess maybe a better way to put it. This is how good you could do. You're a solitary bird. Now, if you're a social bird, what happens is you've got some other issues, because what you're going to do is you're going to try to hide behind another bird when a predator's there. So this is what you're seeing. The B is actually the loss of potential due to this other bird. The other bird being there makes you more conspicuous. So you are going to lose some of your potential fitness. Okay, so for a solitary bird, by yourself is best. But with another bird there, they are lowering your fitness. Now, if you have the other strategy in mind, if you are a social bird, what happens with a solitary bird, you get your benefit, plus you're getting the benefit by hiding behind the other bird. So you're better off, but then you also have a cost of finding the other bird and then staying next to it. So what happens, and then if you have two social birds, you have your fitness, and here you have the loss. But what you're noticing here, you got benefit for one, that kind of counters each other out. So the cost of finding somebody else, making sure that you're in a group and making sure you're in a group of the right size takes it. So what they think is you've got individual animals, you've got social animals, and this is the equation that Hamilton came up with. Is all of these things are in play when they're deciding what to do. And we're, like I said, we're gonna explore that a little bit, I think, in our Zoom session this week. So with that, we will leave it right now.